Hello and Assalamualaikum. In this video, we will discuss an application of differentiation analysis of function. This is our group members, NURIN, SOFIAH, ZAHIRAH, MUTTA'AAL, and KHAIRUNNISA. In this video, we will talk about an introduction to the analysis of function and polynomial function. Next, the problem statement and the problem solution. Lastly, the conclusion.
Analysis of function has numerous applications on various fields. For example, engineering and physics. It is used in the systems engineering process after setting goal and requirements. There are two types: analysis of function 1, polynomial function, and analysis of function 2, rational function. In this video, we are focusing on how to solve polynomial function.
Next, polynomial function. A polynomial function is a function that can be expressed in the form of a polynomial. The definition can be derived from the definition of a polynomial equation. A polynomial is generally represented as px. The highest power of the variable of px is known as its degree. Degree of a polynomial function is very important as it tells us about the behaviors of the function px when x becomes very large. The domain of a polynomial function is entire real numbers. Thus, polynomial function approach power function to very large value of their variables. So, this is example graph of polynomial function. The graph shown as a linear function of fx equal to x plus 1.
Problem statement question fx equals to x cubed minus 6x squared plus 9x. These steps are: 1. Find the x-intercept and y-intercept. 2. Determine the critical points of f. 3. Determine the interval where the graph of fx is increasing or decreasing. 4. Find maximum point and minimum point. 5. Determine the interval where the graph of fx is concave up or concave down. 6. Determine the inflection point if any. 7. Sketch the graph of f.
Number 1. Find x-intercept and y-intercept. To find x-intercept, we should let fx equal to 0. Take the equation and equal to 0. Then, we will solve by factorize the equation to get the value of x-intercept. And x-intercept value are x equal to 3 and x equal to 0. Lastly, we will write the value in the form of coordinate. First is 3, 0 and second is 0, 0. Second step is we will find y-intercept. To find y-intercept, we should let x equal to 0. Take the equation and substitute the value of x, which is 0, and we will get the answer, which same as y equal to 0. Then we will write the value in the form of coordinate, which is 0, 0. Question number 2 is determine the critical point of f. Firstly, we need to find f prime x. Write the equation and differentiate it to get first derivative. Then let f prime x equal to 0. Write the equation equal to 0 and factorize it to find the value of x, which are x equal to 3 and x equal to 1. These are called critical point. Question number 3 is determine the interval where the graph of fx is increasing or decreasing. First, we can draw the critical line and then we can proceed to do the first derivative table. For the first interval, we can refer to the critical line and just pick any number in its range for the test value. Insert the test value into the function, which is f prime x equal to 3x squared minus 12x plus 9. If the answer are positive, it is increasing, and same goes to another one. So here, the increasing interval is equal to negative infinity 1 union 3 infinity, and the decreasing interval is equal to 1, 3. Question number 4 is find the maximum point and minimum point. Now we can find the maximum and minimum point. By drawing this, you can see a point as it located on the mountain. This is the maximum point. As for the other one, you can imagine the point are at the ground. So these are the minimum point. Therefore, when x equal to 1, insert value of 1 into the function and find its value, which is 4. Thus, the maximum point located at coordinate 1, 4. Next, when x equal to 3, insert the value of 3 into the function and we will get 0. So the minimum point is equal to 3, 0.
For question number 5, we need to determine the interval where the graph of fx is concave up and concave down. First, we need to find f double prime x by doing another differentiation on 3x squared minus 12x plus 9 and we will get 6x minus 12. Then let f double prime x equal to 0. It will be 6x minus 12 equal to 0 and we will get value for x which is equal to 2. Then to find concave up or concave down, we need to do a second derivative table. The interval in the table is negative infinity to and to positive infinity. Then we substitute the test value in the f double prime x equal to 6x minus 12. If the answer is in negative, then it is interval concave down. If the answer is in positive value, then it is interval concave up. From the answer, we can determine that the interval concave up is to positive infinity and the interval concave down is negative infinity to.
C. Determine the inflection point, if any. When x equals to 2, the equation is fx equals x cubed minus 6x squared plus 9x. So we substitute 2 into x and then we solve it. And then the answer is 2. So the inflection point is 2, 2. 7. Sketch the graph of f. This is the graph of this equation. We use Desmos to get this graph. From this graph, the maximum point is 1, 4. The minimum point is 3, 0. And the inflection point that we got in the step 6 is 2, 2.
In conclusion, polynomials are algebraic expressions that comprise the variable and coefficients, and they are used to solve problems. In this video, we have covered the basic step for solving polynomial functions. In order to find the maximum, minimum, and inflection point, which is the answer, we are using the differentiation method and derivative tables. Therefore, we have achieved analyzing the function by drawing the graph.